What do sunflowers, seashells, and galaxies have in common? They all hold a hidden mathematical pattern known as the Fibonacci sequence. It's a sequence that begins with 0 and 1, and then each subsequent number is the sum of the two preceding ones: 0, 1, 1, 2, 3, 5, 8, 13, and so forth. It's simple, yet profoundly intricate, like a whisper of order in the chaotic symphony of life. The Fibonacci sequence isn't just numbers on a page. It's a reflection of nature's efficiency, a blueprint that governs growth and structure across the universe. Named after the Italian mathematician Leonardo Fibonacci, who introduced it to the Western world in 1202 through his book Liber Abaci, this sequence has a rich history. Fibonacci was exploring the breeding patterns of rabbits, a seemingly mundane inquiry that led him to stumble upon this extraordinary numerical pattern. Though the sequence existed in Indian mathematics long before Fibonacci, his work illuminated its beauty, allowing it to flourish in the Western consciousness. The Fibonacci spiral is perhaps the most captivating manifestation of this sequence. Imagine drawing squares with side lengths that correspond to Fibonacci numbers, connecting their corners with quarter circles. What emerges is a spiral that expands infinitely, a shape that transcends mere mathematics and resonates deeply with the natural world. This spiral isn't just a figment of imagination. It's a tangible representation of how nature organizes itself. Take a sunflower, for instance. Within its vibrant center, the arrangement of seeds reveals two distinct sets of spirals, one winding clockwise and the other counterclockwise. The numbers of these spirals often correspond to Fibonacci numbers, like 34 and 55. This intricate pattern allows the seeds to be packed tightly, maximizing space and efficiency, a clever design that ensures the sunflower can thrive in its environment. But the Fibonacci sequence doesn't stop with flowers. It echoes throughout nature in various forms. Nautilus shells, for example, exhibit Fibonacci spirals in their growth patterns, while pine cones display Fibonacci arrangements in their scales. Even the swirling arms of galaxies and the spirals of hurricanes are shaped by the same mathematical principles. In each instance, the Fibonacci sequence emerges as nature's way of optimizing growth and structure, a silent architect behind the beauty we observe. The animal kingdom, too, is not exempt from this mathematical wonder. Consider the family tree of the male honeybee. Male drones have one parent, the queen, while female workers have two. If you trace the ancestry of a drone backward, you'll find that the number of ancestors in each generation forms a Fibonacci sequence. It's a fascinating glimpse into how these patterns resonate even within the intricate web of life. Human beings have long drawn inspiration from the Fibonacci sequence as well. The golden ratio, closely related to Fibonacci, has been utilized for centuries in art and architecture. This ratio, approximately 1.618, emerges when you divide one Fibonacci number by its predecessor as the sequence progresses. Many artists and architects have harnessed this ratio, believing it embodies aesthetic beauty. The Parthenon, Leonardo da Vinci's Vitruvian Man, and countless other masterpieces are steeped in this mathematical elegance, creating works that resonate with the viewer on a profound level. In the realm of finance, the Fibonacci sequence reveals its practical applications. Traders often use Fibonacci retracement levels to predict potential support and resistance points in stock prices. While the effectiveness of these tools is debated, their presence in financial analysis speaks to the universal appeal of Fibonacci, bridging the gap between art, nature, and economics. Even at a microscopic level, Fibonacci whispers its secrets. The structure of DNA, the very essence of life, aligns with the golden ratio in its proportions. The human body, too, exhibits Fibonacci patterns in the proportions of bones and facial features, a reminder that this sequence is woven into the very fabric of our existence. Look up at the night sky, and you may see Fibonacci in the arrangement of galaxies. Spiral galaxies, like our Milky Way, form shapes reminiscent of Fibonacci spirals, hinting at a cosmic order that transcends our understanding. So why does Fibonacci appear so often in nature? Many scientists believe it represents the most efficient way to grow and arrange objects in space. Whether it's the seeds in a sunflower or the leaves on a stem, Fibonacci helps maximize exposure to sunlight, nutrients, or other resources, a testament to the elegance of natural design. The Fibonacci sequence is more than just a series of numbers. It's a key to unlocking the mysteries of the world around us. From the spirals in sunflowers to the galaxies above, Fibonacci reveals the underlying order in what might seem like chaos, inviting us to marvel at the intricate patterns that connect all life. It's a reminder that, in the heart of nature, mathematics and beauty are intertwined, whispering secrets to those who dare to listen.